Hello, welcome you all in this new video, and today video is going to be very interesting because in this video we are going to discuss about the Lagrange points. Okay, you searched out anywhere in the YouTube or in the Google, you will not find the exact logical explanation why these kind of points exist between the two mass bodies. Okay, and if you search out on the Google, majority around 98% of the videos which has been made on these points in the YouTube, or you searched out in Google, they will say that this is a point between the two mass bodies where the gravitational pull of the both the bodies is going to neutralize. Okay, I agree with this condition, but we cannot say that only with this concept we can explain all the Lagrange's point. Okay, Lagrange points doesn't means only these are the points which exist in the earth and sun system. Okay, any two mass bodies where one mass body is bigger than the other, okay, there exist these kind of the points. Okay, so my point here is that in this video we will explain why these Lagrange points exist and how they exist and how we can find that where they will exist between the two mass bodies. Okay, so guys, I agree with this condition that majority of the explainer tells us that Lagrange points exist between the two mass bodies where the gravitational pull is going to neutralize. Okay, I agree with this condition, but this is not the exact and absolute explanation. Okay, why this point exists there. Okay, for example, let's say this is your sun. Okay, this is your earth, and this concept can be explained only for the L1. If I talk about what about L2, the L2 point is outside the earth. Okay, that is not in between the earth and sun. Okay, so how you can explain the stability at the point L2? Okay, that I will explain, guys. In this video you will get complete explanation with logical way. Okay, and I will use the fundamental physics here to explain all these things, and it is very easy and very interesting, so that's why this video becomes very important, guys. So let's start our video. So guys, this is all about the picture you are seeing on your screen. Okay, these are the pictures of Lagrange points, okay, in the earth and sun system. Okay, so as you can see, here is our Aditya L1, our solar exploratory mission. Okay, which we had Aditya L1, and Aditya L1 it is at the point L1, so it is named as Aditya L1. Okay, it is between the sun and earth. So first of all, let's understand what is this Lagrange points. Okay, Lagrange point. So what is this, guys? Simply, if I tell you, Lagrange point is the point between the two mass bodies, or in the system of two mass bodies where one mass body is bigger than the other mass bodies. Okay, and at that point, or in the place of at that point. Okay, like for example, here is a point. Okay, L1, I am considering, let's say L1 is the point between the sun and earth, and Lagrange point is the point in the system of two mass bodies where any object become stable or need very less fuel to become stable. Okay, so in our system, earth and sun system, we have 5 Lagrange's point. Okay, I am not telling, guys, that Lagrange points exist only in the sun and earth system. Any two mass bodies, they will exist anywhere. Okay, so this is all about what the Lagrange point is. Okay, and if I tell you that in Lagrange point L2, okay, we have our James Webb Telescope, and now in the point L1 we have our Aditya L1. Okay, so these are placed in these 2 points. Why? Because these 2 points are very stable. Okay, so like our telescope never, if telescope is in the condition that where it will affect by the solar light, so it will not be able to capture the whole galaxy, so it will be away from the sun and in a position where it cannot get directly contacted with sun. Okay, so this is the position of L2, and telescope need a very stable condition to capture the pictures, okay, and to study the galaxies. So that's why we placed our James Webb Telescope in L2 and L1. So it's a separate matter completely. Let's come back to our main topic, that is Lagrange's point. Okay, these are the 5 Lagrange's point. Okay, and now let's explain what is the reason behind it. Okay, And how we can calculate that between the two mass bodies, where we will consider that yes, this is the point where the Lagrange point is, means the condition or the place where the stability, where the object can be in the stable form, okay, means where the gravitational pull of the both the bodies will not affect, okay, means it will be in the stable form. So let's explain that. So guys, before I tell you about the Lagrange points and how it is been calculated, let's consider, first of all, let's understand the two basic concept, okay. Let's understand two basic concept. So these are very simple basic physics concept, okay. One is force and one is angular velocity, okay. These two concepts. What is the force, guys? And in mass bodies, which kind of force are interacting there and how they are interacting there? You just understand simply these two concepts, and these are very simple, guys, okay. For example, let's say that this is our sun, okay, and this is our earth, and earth is revolving around the sun like this, okay. And so when a mass body is revolving or coming in the contact with another mass body, there is a force that is called gravitational force, okay. Gravitational force is acting on these two particles, these mass particles, okay. And there is another force, guys. When this earth is revolving in the rotational motion around the sun, okay, so there will be another force, that is centrifugal force, okay. Because of this centrifugal force, which is away from the center, means this will be outward. It means what? Why the earth is stable in its orbit? It's because of the balance or equilibrium between the gravitational force and the centrifugal force, okay. These two forces are acting on it, guys. Just remind and just keep in your mind, okay. We will use this concept to explain the Lagrange points, okay, why that is so. And another concept is angular velocity. Angular velocity, guys, remind one thing, okay. Always remember, whenever you read, you see, okay, you listen angular anywhere, always think it's about rotation, okay. It's about rotational motion, okay. It's about rotational motion. Let's say here is a point, and here is the, let's say this is our circular path. A body is moving in this circular path like this, okay. Let's say this position is A, okay. And I tell that in 1 minute, let's say after some time, this body moves to point B, okay, like this. And now this origin is O, and let's say this position is B. A particle move in a circular motion from point A to point B, okay. When it is moving like this, it makes a small angle or some quantity of the angle with respect to this origin. Let's say this is theta, okay. How much theta it has traveled in how many times, okay, in what time? That is called what? Angular velocity, okay. That is what? Angular velocity, okay. Guys, remind simply the change in the angle with respect to the time. How much angle is changed means how much angle is changed. Angle is changed means it shows your rotational displacement, okay. How much angle is changed in how much time, that is called angular velocity, okay. Keep these two concepts in your mind, and we will use in these two formula, okay, to explain the Lagrange points, why they are stable and how we can find that they are stable in which location, okay. Let's start. Now be careful, guys. So let's say this is our sun. It's not necessary that, I told you earlier, it's not necessary that only earth and sun will have Lagrange point. Any mass bodies can have, okay. Let's say I'm just taking the example of sun and earth, so because you are familiar with this thing, so it will be easy for you to understand these things, okay. So let's say this is our sun and this is our earth, okay. And before I tell you how to locate and how to find the Lagrange point, let's understand one thing. What do you mean and why we need Lagrange points? Why we need Lagrange means nothing, stable point, okay. Lagrange points, okay, this is our question. And let's say stable point, why we need a location, okay, where the object can be more stable between the two objects, okay. Why we need Lagrange point means what? The place, if we place any object on that place, okay, that will be in the consistent with earth. Earth means small body, which is a small body, okay, which is revolving. If we place any object on that point, okay, which we are called Lagrange point, that should be consistent with the earth motion. Remind this, guys. Okay, so now let's come back to this example. Okay, this is our sun and earth system. Okay, let me write here sun and earth system. Okay, let's say, guys, here is a point. Okay, let's say our Aditya L1 is in this point. When I am explaining this, please don't confuse yourself like this. Okay, just clean your mind, and you know that, and think that I don't know nothing. You don't know what's the Lagrange point, what's the force, which kind, what's acting in there. Okay, just simply understand it in a very simple way. Okay, like this. This is, let's say, this is our Aditya L1. Okay, and let's say our earth is revolving with the angular velocity of, let's say, 30 radian per second. Okay, radian is nothing, it's the angle unit. Okay, change in the angle unit. I'm just taking its hypothetical example so that it will be easy for you to understand. Actually, what is the angular velocity of the earth? That is 1.99 into 10 raised to power minus 7 radian per second. Okay, this is, so I'm not taking, this will take too much calculation and you will distract from main concept. Okay, let's understand, let's take it like it's a 30 radian per second. It's just an example. Okay, and these three are in the one line. Okay, earth and this Aditya L1 and the sun are in the same line. Okay, and let's say that Aditya L1, it moves with the angular velocity of 14 radian per second. Okay, if this is the case, let's say after 5 minutes. Okay, I take 5 minutes time, and this is our sun, and this is our Aditya L1, and this is our earth. Look at, guys, both Aditya L1 and earth, they are not in the same line. Okay, it means what? We need a point which will be consistent with the earth. Okay, so we have to find that point within this. Okay, it means what? It means that, let's say, this was the actual location. Okay, and let's say this earth moves or takes, or what's the circular displacement, that is theta1, and what this Aditya L1 moved, it moved with the angle theta2, means it traveled the distance, rotational distance theta2 with respect to the sun in a circular orbit. Okay, so it means what? This point is not able to usable for us. Why? Because we need a point which is consistent with the earth. And what does this mean, guys? It means that the rate with which earth is revolving around the sun, okay, means the rate with which earth is displacing in the rotational displacement. Okay, so it means that theta1 should be equal to theta2, means that in the same time they should travel the same rotational displacement, means there should be the same angle difference or same angle displacement. Okay, so it means what? It means your angular velocity should be constant. Okay, constant with respect to what? With respect to earth. Okay, it means that, guys, Lagrange point is nothing, it is a point between the two mass bodies. Okay, where any object which is placed there, okay, moves with the same angular velocity as that small mass body is moving, okay, with respect to the big one body. Let's take the example of the sun. Okay, sun is here. Okay, and we placed Aditya L1 on this point and earth is here. So as with which rate earth will revolve, the Aditya L1 will also move with the same angular velocity. When they are moving with the same angular velocity, it means that they are consistent with each other. Okay, Aditya L1 will always in between the earth and sun. Okay, and same logic is applied for the L2 also. We have to choose a point outside, okay, away from the earth, in a such a way that whose angular velocity will also be same as the earth. Means what? Here Lagrange's point concept comes because we need a point in the space, in the solar earth and sun system, in such a way that where object can be stabilized. Stabilize means stabilize with respect to the earth. Stabilize with respect to the earth means consistent with respect to the earth. Okay, so that's why they are revolving. So if they are revolving consistent, means angular velocity should be constant, so that they can be in the same place where we had placed that. Okay, so this is all about why and where we have to find, where we will find the this Lagrange point. Okay, Lagrange point will be any point where the angular velocity can be adjusted in such a way that the angular displacement is same or angular velocity remain constant. So main funda is not only about the force. I agree with this condition that force get neutralized, but more important than force, that is this: what your force will do only one work, guys. Your force will keep that object in the place where it is, or keep in the orbit, in the rotational motion. Okay, but not it cannot, only force cannot decide that where will be the point, and neither force can tell you that how much displacement will be there. Okay, so we need two concepts. First is force, that I told you, gravitational force and centrifugal force, and another concept is the angular velocity should remain same with respect to the small body which is revolving around that bigger mass body. Okay, so that's why we get that Lagrange point. I hope this concept is clear to you. Now just take a look on this picture. Okay, and here is our L2 point. Here is our L2, and it is our L1, L4, L3 and L5. There are 5 points, 5 Lagrange points, okay, in the Sun and Earth system. Okay, so we used mostly the 2 points, L1 and L2. Why? Because these are near the Earth. So like we are sending any kind of the observatory mission, so it is necessary for us to take or to remain in the continuously connection or communication with that. Okay, so that's why we prefer the L1 and L2. These 2 points are which are stable and near the Earth, so that's why these two are very useful for exploratory mission, like our Aditya L1, in the L1 location, to observe and to measure all kind of the phenomena of the sun. Okay, and here we have L2. Okay, L2, in L2 point we have James Webb Telescope. Okay, all these things are, James Webb Telescope will cover whole the galaxies and will tell us what's there in the galaxy. Okay, so this is all about the Lagrange points. Okay, I hope you like this video, and let me summarize all the concept what we did. We did Lagrange points. Okay, what does mean Lagrange point? Between the two mass bodies. Okay, and one mass should be greater than the another mass. Okay, another thing we did, we will establish where that place will come. Okay, through the two concept, that is force, and second one is angular velocity. Okay, so these two concepts we used in this video, and we found out that why the Lagrange points exist and what it is. Okay, and why Aditya L1 is placed in the L1 location and James Webb Telescope in L2 position. Okay, I hope you like this video, and if you like our initiative, then give a thumbs up and do subscribe our channel. Thank you so much.